We've always believed we were the first to split atoms, to alter the climate, to build machines capable of reshaping an entire planet. But what if that belief is wrong? Deep in ancient rock, ice and ocean mud lie clues that don't fit our story. Metallic spheres formed by intense heat, sudden carbon spikes frozen in prehistoric ice, traces of radiation locked in stone long before humans existed. Scientists call this the Silurian Hypothesis. Proposed by NASA's Gavin Schmidt and astrophysicist Adam Frank, it asks a haunting question. If others came before us and failed, what does that mean for us now? Our journey into Earth's hidden history begins not with the ruins of cities or the bones of giants, but with something so small it's easy to overlook. Tiny metallic spheres, some barely larger than grains of sand, others small enough to balance on a fingertip. They've been locked inside ancient rock for unimaginable spans of time, and yet their existence raises a question that cuts to the heart of everything we think we know. Are we really the first civilization to walk this planet? To understand why these little spheres are so unsettling, we need to start with what we already know about them in the modern world. When the first nuclear bombs were detonated in the mid-20th century, scientists carefully studied the aftermath. They found what you'd expect: craters, shattered buildings, scorched landscapes. But they also found something much stranger. The incredible heat of the explosions had vaporized soil and stone, and when those materials cooled as they fell back to Earth, they formed tiny, perfect glassy beads. These are called microspherules, and they are one of the clearest geological fingerprints of nuclear fire. Move ahead millions of years. If another species were to dig into our planet long after we're gone, they wouldn't find our cities or our satellites, but they would find these spheres scattered in the soil. Even if every trace of us vanished, these little beads would remain to tell the story. Someone here learned to split the atom. That's what makes the discoveries in ancient rock so haunting. Nearly identical spheres have been found in geological layers far older than humanity itself. In South Africa, miners cutting into deposits of pyrophyllite, a soft rock used for industry, stumbled upon hundreds of them. Some were smooth and nearly perfect. Others had fine grooves etched around their middles, almost like manufactured ball bearings. Their composition was metallic, with high levels of hematite and other minerals not expected in such a context. Most shocking of all, the rock that encased them was over 3 billion years old. That's a time when Earth was a hostile microbial world. By everything we know, no complex life existed, certainly nothing capable of precision engineering. The objects became known as the Klerksdorp spheres, and ever since they've been a quiet controversy. Officially, geologists argue they're natural concretions, unusual but not impossible formations created when minerals cluster together under the right conditions. But others remain skeptical. Some of the spheres are balanced so precisely they can roll straight across a surface, which even modern machining struggles to achieve. Photographs of spheres with perfect symmetry and neatly carved grooves only fuel the debate. And the mystery isn't confined to South Africa. Similar metallic microspherules have been found in other parts of the world, sometimes embedded in layers tens of millions of years old. Many contain nickel and chromium in unusual ratios, remarkably similar to those produced in modern metallurgy, and, more disturbingly, in nuclear detonations. Volcanic eruptions and asteroid impacts can produce spheres too, but their chemical profiles don't match what we're seeing in these ancient samples. Natural processes tend to create wide variation. These are consistent, uniform, almost as if mass-produced. Even more intriguing, some layers rich in microspherules line up with extinction events. Entire ecosystems blink out of existence, and right there in the same strata, geologists find a scattering of metallic spheres. Mainstream explanations point to asteroids or volcanic winters, but another possibility lurks in the data that at least some of these layers mark not natural disasters, but technological ones. Nuclear fire, fallout on a global scale. Now, it's important to be cautious here. Extraordinary claims require extraordinary evidence, and a handful of spheres is not enough to rewrite the timeline of civilization. But the coincidence is hard to ignore, because if an advanced society once lived on Earth, these spheres are exactly the kind of clues we would expect to survive. Not their cities, not their art, but the chemical and geological scars of the forces they unleashed. Imagine for a moment a distant future, millions of years from now, long after humanity is gone. Our concrete will have crumbled, our steel rusted, our glass turned back into sand. But a layer of radioactive isotopes will remain in the soil. Tiny fragments of plastic will be trapped in the oceans, and scattered through the sediments will be billions of microspherules, the legacy of our nuclear age. Future scientists would not need to see our monuments to know we once existed. They would only need to find these fingerprints. And so we're left with an uncomfortable symmetry. In the present, our own technology leaves behind markers that future civilizations could recognize. In the past, we found markers that look almost the same, but with ages that defy our history. If they're natural oddities, then they are remarkable coincidences. If they are artificial, then we are not the first. The truth remains buried in stone. But the fact that the debate exists at all forces us to look closer at the other puzzles Earth has left us. Because the mystery of the spheres is only the beginning. When we turn to the story of life itself preserved in the fossil record, we find gaps so large and leaps so dramatic that they challenge our understanding of evolution. Patterns that almost feel like the work of unseen hands, nudging life forward or erasing it altogether. And that's where our journey leads next, into the fossil record, a book where entire chapters are missing, and where the pages that remain hint at something far stranger than natural history alone. The fossil record is often described as a book, a long, detailed story of life on Earth. But when you actually open that book, what you find looks less like a smooth story and more like a jigsaw puzzle with half the pieces missing. There are sudden leaps, inexplicable appearances, and entire chapters that seem to have been torn away. And the deeper you look, the stranger it gets. The most dramatic example comes from what scientists call the Cambrian explosion, roughly 540 million years ago. For billions of years before it, life was simple, mostly microbes, algae, and tiny multicellular organisms. Then, almost overnight in geological terms, the world changed. Creatures with shells, eyes, nervous systems, and complex body plans appeared out of nowhere. Dozens of new phyla, the highest categories in biology, emerged within just a few million years. That may sound like a long time, but on the scale of Earth's history, it's a blink. Evolutionary theory tells us that life changes gradually through mutation and natural selection, and in many cases the fossil record supports that. But during the Cambrian, the rate of change seems almost impossible. Instead of slow branching, it looks like an explosion of complexity. Darwin himself admitted it was one of the greatest puzzles for his theory. Today, scientists explain it by suggesting that environmental conditions suddenly allowed for better fossilization, or that genetic thresholds were crossed that made rapid diversification possible. And maybe that's true, but there's another possibility. One most scientists avoid, but that lingers like a shadow. What if something else was pushing life forward? The Cambrian explosion isn't the only anomaly. Again and again, in the hundreds of millions of years that followed, we see sudden arrivals of entirely new species with little or no sign of ancestors. Mammals appear, then diversify rapidly after the dinosaurs vanish. Flowering plants dominate ecosystems seemingly overnight. Even humans appear strangely quickly, with brains that tripled in size in just a few million years. Each of these leaps could be explained by chance, but when you line them up, the pattern begins to look suspicious. And then there are the extinctions. 5 times in Earth's history, nearly all life was wiped out in global cataclysms. Asteroids, supervolcanoes, shifting climates. These are the standard explanations. But what if, in at least some cases, the extinctions weren't purely natural? What if they were the collapse of civilizations we've forgotten, their end marked not by craters and lava, but by their own mistakes? If we disappeared today, the sudden vanishing of most large animals, elephants, whales, livestock, would puzzle any future scientist. They might think it was climate or cosmic impact. Only by digging deeper into the chemistry of the rocks would they discover the truth. It was us. The fossil record is incomplete by nature. Soft-bodied organisms rarely leave traces. Entire environments vanish without a mark. But sometimes, what's missing tells a story just as loudly as what remains. When life makes leaps that seem too big, or vanishes without a clear cause, it forces us to consider possibilities outside the usual explanations. Maybe the record looks broken because the story of life itself has been interrupted, reset, or guided in ways we don't yet understand. And if that's true, then life's history is not just random chance. It may be the layered record of civilizations rising, influencing the world around them, and then vanishing, their traces left not in monuments, but in the strange rhythms of evolution. But fossils aren't the only record of the past. If civilizations altered Earth, their fingerprints might not just be found in bones and shells, but in the very air itself. And that brings us to another anomaly, frozen in ice and locked in atmosphere. Evidence that looks eerily like the scars of industry. One of the most powerful tools scientists use to study Earth's past is ice. In Greenland and Antarctica, cores drilled deep into glaciers reveal bubbles of air trapped tens of thousands, even hundreds of thousands, of years ago. Each layer is like a snapshot of the atmosphere at the moment it formed. By analysing these bubbles, we can reconstruct the climate, charting rises and falls in temperature, carbon dioxide and methane across ages. It's like opening time capsules from Earth's breathing past. Most of the patterns we see are natural, ice ages waxing and waning, carbon cycling with the growth of forests and oceans. But here and there, something strange appears. Layers where carbon dioxide spikes dramatically, then stabilizes again, as if something had rapidly burned huge amounts of organic material. Sudden pulses of methane, far beyond what natural wetlands or volcanoes could produce. In some ice, faint traces of compounds that don't belong at all. Chemicals that look suspiciously like industrial byproducts. The official explanations are cautious. Maybe massive wildfires raged. Maybe volcanoes released unusual gases, but the sharpness of the spikes and the way they echo what we're doing right now is unsettling. Our own industrial footprint is unmistakable. Carbon dioxide rising faster than in any natural cycle, methane surging from agriculture and industry, synthetic chemicals drifting into the sky. If we vanish tomorrow, those markers would be locked into ice and sediments for millions of years to come. And so when we find similar markers in layers long before humanity, we have to ask, who or what put them there? There's also the problem of warming events. Geologists have identified periods when Earth suddenly grew hotter, far beyond normal climate swings. One of the most famous is the Paleocene-Eocene thermal maximum, about 55 million years ago, when temperatures spiked globally, oceans acidified, and ecosystems collapsed. The cause is debated: volcanic activity, methane release, or an asteroid impact. But the chemical signatures in the carbon look disturbingly like what you'd expect from massive fossil fuel burning. The same fingerprint we're leaving today. Was it just a natural coincidence? Or was it the industrial scar of a civilization that burned too hot, too fast, and vanished in its own greenhouse storm? Skeptics argue we're stretching the data too far. They remind us that natural systems can produce strange patterns, and that extraordinary claims need more than unusual numbers, and that's fair. But if we consider how little would remain of us in 10 or 20 million years, the case becomes stronger. Our skyscrapers would vanish, our satellites would fall, but the gases in the air, the isotopes in the soil, the sudden chemical scars in the ice, those would endure. And if someone found them, millions of years later, they might wonder the same thing we're wondering now. The atmosphere doesn't just record weather, it records civilization. And if civilizations came before us, their rise and fall may be written in invisible ink, frozen in bubbles of ancient air. But air and ice are only part of the story. There's another record, one far more dangerous, locked not in gases but in the very atoms of the Earth. A record that suggests someone long ago may have unleashed the fire of the nucleus itself. In 1972, inside a uranium mine in Oklo, Gabon, scientists made a discovery that shook the foundations of physics and geology alike. At first glance, the ore looked ordinary, uranium-rich rock like that mined in many other places. But when researchers tested its isotopic composition, they found something impossible. The uranium had already been burned. The isotope ratios were the same as what you'd expect from fuel rods inside a nuclear reactor. In other words, at some point in deep time, chain reactions had occurred inside the Earth itself. This was a staggering revelation, because natural reactors were thought to be impossible. And yet, here was undeniable evidence. Self-sustaining nuclear fission had taken place nearly 2 billion years ago. Geologists rushed to explain it. Conditions at Oklo were uniquely perfect. Groundwater slowed down neutrons just enough to sustain the chain reaction. Nature, against all odds, had built its own nuclear plant. But the discovery also proved something else. Nuclear signatures are extraordinarily durable. Even after billions of years, the isotopic fingerprints of those reactions remained sharp and clear in the stone. That realization opened a disturbing question. If our own civilization were to vanish tomorrow, nuclear traces would last long after our cities eroded away. The fallout from weapons tests, the spent fuel buried underground, the radioactive isotopes seeded across the planet, all of it would still be detectable millions of years into the future. Nuclear activity, once unleashed, cannot be hidden from time. Which brings us to the puzzle. Why do we find nuclear-like signatures in rocks that predate humanity by tens of millions of years? In Kazakhstan, uranium deposits contain isotope ratios eerily similar to those created in controlled tests. They don't match what natural reactors like Oklo would produce. Instead, they match what a weapons blast leaves behind. Across 6 continents, geologists have recorded anomalous layers containing artificial-seeming isotopes: plutonium, cesium, strontium, elements that don't occur naturally in the concentrations where they were found. Some are the kind of isotopes modern reactors produce only under tightly regulated conditions. And yet, here they are, frozen in ancient stone. One sample pulled from Greenland's deep ice cores contained radioactive isotopes that would have required technology more advanced than anything humans had built until the mid-20th century. That ice was hundreds of thousands of years old. If those isotopes weren't natural, then someone, or something, left them behind long before us. The implications spiral outward. Sediment from the Pacific shows plutonium traces that line up almost perfectly with one of Earth's greatest extinction events. If natural disasters had been responsible, we'd expect volcanic gases, asteroid debris or methane spikes. Instead, we see isotopes that can only come from nuclear detonation. Was it coincidence? Or were we staring at the chemical shadow of a war that wiped out entire ecosystems? What makes the evidence more unsettling is how systematic it looks. In some formations, isotopes appear in neat pulses. Intense activity, then nothing, then another pulse thousands of years later. It's the pattern you'd expect from a society testing weapons, not a chaotic geological process. Ancient myths, strangely, seem to echo this. In India's Mahabharata, warriors unleash weapons that make the sky glow like a second sun. Whole cities vanish in blasts that leave survivors hairless and ill, their food poisoned. Mainstream historians see allegory, poetry, or exaggeration. But when compared with the geologic record, these stories sound eerily familiar. To be clear, science hasn't declared any of this proof. Natural explanations always exist, and caution is necessary. Yet every anomalous isotope, every radioactive fingerprint in the fossil record forces us to ask, are we really the first? Or are we walking across the ashes of predecessors who split the atom long before us, only to destroy themselves in the fire they unleashed? Because if nuclear ghosts linger in the rock, they are not just records of destruction, they are warnings, and if we fail to listen, then we too may become nothing more than another layer of isotopes buried in the stone. One more vanished civilization in Earth's repeating cycle. If you want to know what will define humanity's presence on Earth, don't look at the tallest skyscraper or the largest city. Don't even look at monuments carved in stone. Look instead at plastic. From the first cellophane wrappers to the oceans of microplastics now drifting in every current, our world is saturated with it. Plastic particles fall in rain, settle in snow on remote mountaintops, and swirl in deep ocean trenches. Scientists have even found them frozen in Arctic ice and embedded in the organs of animals. Long after our machines rust and our glass crumbles, plastic will remain, pressed into sediments and fossilized into new rock. Geologists call this future layer the plastiglomerate, and it may be the single clearest geological signature of our age. Now imagine finding something like that in rocks far older than humanity. That's exactly what some researchers claim to have discovered. While drilling cores from the Pacific and Atlantic seabeds, scientists uncovered polymer-like fragments in sediments dating tens of millions of years back. At first, the explanation was simple: contamination. Modern drills, storage tubes, or even lab equipment could easily introduce plastics where they didn't belong. But contamination checks grew stricter, and in certain cases the anomalies persisted. Some fragments were buried too deep, in layers sealed long before humans evolved. Under microscopes, they looked nothing like natural polymers such as amber or bitumen. Instead, they showed repeating molecular chains, organised, synthetic-looking structures more like polyethylene or nylon. To make matters stranger, some of these fragments resisted heat and ultraviolet breakdown better than modern plastics. If they weren't contamination, they might represent engineered materials designed to endure for geological time. Materials, in other words, that someone meant to last. And plastics aren't the only anomalies. Tiny metallic beads and fragments have been found in sediments around the world. Their chemical makeup sometimes shows alloys, combinations of metals like nickel, chromium and iron, that rarely occur together naturally. In certain cases, they mirror the compositions used in modern stainless steel. Volcanic activity or meteorite impacts can fuse metals in strange ways, but the uniformity of these samples suggests intention rather than accident. To be clear, most geologists treat these reports with caution. Contamination is the simplest answer, and extraordinary claims demand extraordinary evidence. But patterns matter. A fragment here or there could be dismissed. A scattering of them across oceans, continents and layers begins to whisper of something larger, of activity that flared briefly in deep time, then vanished. Think of how our own footprint will look millions of years from now. Imagine a geologist in some distant future drilling into the crust. They won't find intact skyscrapers or rusting cars. They'll find a thin horizon filled with strange materials, aluminum nearly absent in nature until humans smelted it, synthetic polymers unknown to biology, alloys arranged in ratios nature rarely produces, a chemical soup of fertilizers, pesticides, and industrial byproducts. To them, we will be a layer of anomalies, unmistakable but fragmented. So when we look at ancient sediments and see polymer-like fragments and engineered-looking alloys, the mirror effect is hard to ignore. These are exactly the kinds of traces our own civilization is leaving behind. If they are contamination, they are frustrating coincidences. If they are genuine, they are whispers of predecessors who rose, industrialized, and left only their garbage behind, just as we are doing now. There are even stranger claims on the fringes of archaeology, out-of-place artifacts, objects that appear to defy the age of the rock around them. A metallic sphere found inside a 600-million-year-old lump of coal, a chunk of aluminum resembling machine parts pulled from a Romanian quarry. Most of these are dismissed as hoaxes or misinterpretations, and many probably are. But the persistence of such stories, combined with genuine anomalies in sediments, keeps the question alive. What if some are real? What if they are relics of industries erased by time? What makes this idea chilling is how invisible industrial civilizations would become after collapse. A few thousand years, and forests would reclaim cities. A few million, and glaciers and oceans would erase the landscapes entirely. But the materials, the plastics, the alloys, the durable synthetics would remain, buried and waiting. And that is perhaps the greatest warning. We are producing the very evidence that would convict us as a civilization, even if all else fades away. Plastics that will outlast our languages, alloys that will outlast our governments, chemical fingerprints that will outlast our species. Someday, another intelligence could look at our traces and wonder, as we now do, whether they are seeing the legacy of a people who rose, burned brightly, and then disappeared. If Earth hides such materials from earlier ages, then perhaps they are not accidents at all. Perhaps they are the fingerprints of civilizations that came before, who reached into chemistry and engineering, scattered their creations across the planet and then were lost to time. And if they reached that point, why assume they stopped at Earth's surface? For if industry and technology once existed here, the next logical step is outward, into orbit, onto the moon, into the solar system itself. And that is where we now turn to the evidence that may lie not in stone or ocean, but beyond the Earth itself. When we think of civilizations, we picture them rooted to the Earth, bound to rivers, plains and coasts. But in just a handful of generations, humanity has leapt from stone tools to spaceflight. We've put satellites into orbit, footprints on the moon, and probes beyond the solar system. If our story ended tomorrow, some of our most enduring traces wouldn't be on Earth at all. They'd be floating above it, or waiting silently on airless worlds. And that raises a haunting question. If we've already spread artifacts beyond our planet in just a century of industry, what if another civilization had millions of years to do the same? If they reach for the skies, what clues might they have left behind? The first whispers of this possibility came not from telescopes but from radio antennas. In the early decades of the space age, engineers noticed something odd. Long-delayed echoes. Radio signals sent from Earth sometimes bounce back several seconds later, far longer than normal reflections. Some scientists thought it was atmospheric interference, or reflections from the moon. But others wondered, what if something artificial was out there, catching and replaying our signals like a mirror in the sky? The phenomenon was never fully explained, and it faded into obscurity. Yet it planted the seed of an idea. Maybe Earth's orbit isn't as empty as it seems. That idea exploded into public imagination with the story of the Black Knight satellite. In the 1960s, radar operators detected strange objects in polar orbit at a time when neither the United States nor the Soviet Union had satellites in that position. Later, during missions in the 1990s, astronauts photographed a dark, angular object drifting above Earth. NASA insisted it was space debris, likely a lost thermal blanket, but to many, it looked too strange, too deliberate. Conspiracy theories spread, claiming the Black Knight was an ancient satellite, perhaps thousands of years old, left by a forgotten civilization. The truth is probably mundane, but the symbolism lingers. If humanity collapsed tomorrow, our satellites would continue circling Earth for centuries. Some, in stable orbits, could last tens of thousands of years before decaying. To any future intelligence, they would appear just as mysterious as the Black Knight does to us. If orbit is the first place to look, the Moon is the second. Unlike Earth, the Moon has no atmosphere, no weather, no erosion. Artifacts there could last millions, even billions of years. Already, Apollo astronauts left behind flags, rovers, and scientific instruments, silent markers of our presence. If another civilization had visited long before us, their traces could still be up there, buried just below the dust. Some anomalies fuel speculation. Reflective flashes seen in craters, glassy beads scattered across the surface in unnatural clusters. Officially, these are explained as volcanic glass or impact melts. But what if some are remnants of industrial processes? Mining slag or debris from ancient activity? It's a provocative thought, especially when we remember how permanent the lunar surface can be. If we can leave tracks that may last millions of years, why couldn't others have done the same? Then there's Mars. Billions of years ago, it was a world of lakes, rivers, and perhaps oceans. If life had the chance to evolve there, intelligence might have followed. When Viking probes sent back the first close-up photos in the 1970s, one image electrified the world. A mesa in the Cydonia region that, in the shadows, looked like a colossal face. Later, higher resolution images revealed it as just a natural formation. But the excitement it caused revealed something important. We are primed to see meaning in anomalies, and yet Mars still holds mysteries. Meteorites blasted from its surface contain unusual microstructures, once argued to resemble fossilized bacteria. Certain mineral deposits suggest chemical processes that, while explainable, don't quite fit natural expectations. If Mars once had an intelligent civilization, its ruins could be buried under kilometers of dust and sand, invisible to orbiting cameras. Only deep exploration, drilling, excavation could confirm or deny it. And given Mars's ancient habitability, the question remains tantalizing. Beyond Mars, we reach the asteroids. To us, they are treasure troves of metals: iron, nickel, platinum, cobalt. Already, companies are planning to mine them, and if we succeed, the scars of excavation will remain visible for millions of years. Some asteroids already show oddly geometric ridges or grooves that don't quite match natural models of rotation and impact. Most are probably coincidences of geology, but again, we're forced to consider the mirror. If we would leave those marks, why not others? Some scientists even suggest searching for technosignatures closer to home. Instead of scanning the stars for alien radio signals, what if we scoured our own solar system for debris, artifacts, or mining scars left behind by civilizations that came before? In recent years, the idea has gained traction. A rock like Oumuamua passing through our system sparked debate about whether it was natural or a fragment of technology. If fragments of civilizations can drift between stars, then evidence might be closer than we think. This leads to a sobering thought. If traces exist in orbit, on the Moon, on Mars, or in the asteroid belt, they may outlast every other clue on Earth. Our planet erases itself, with erosion, with tectonics, with oceans. But space preserves. Artifacts up there may be the truest legacy any civilization can leave. So as we stare into the sky, we might not just be looking outward for others among the stars, we may be looking backward into the deep past of our own world. And if we find something, the question that will echo louder than any other is not just what they left behind, but why they vanished. And that brings us to the final, most unsettling part of this journey. The repeating pattern of civilizations rising, shining, and falling into silence. When we tell our own story, we tend to imagine it as a straight line, a journey from caves to cities, from sparks of fire to nuclear stars, from myths to science. But history rarely moves in straight lines. It loops, it collapses, it erases itself. And when we zoom out far enough, past the rise and fall of empires, past the flicker of cultures and kingdoms, what we see is a rhythm. Civilizations don't just rise, they rise and they fall, again and again. The Romans believed they had built something eternal. Their aqueducts cut across Europe, their armies stretched from the Atlantic to the Middle East. But drought, disease, corruption, and the slow, grinding weight of overextension brought the empire to its knees. The Mayans built vast cities hidden in the jungles of Central America, aligned with the stars, glowing with art and science. And then came collapse, environmental stress, war, shifting trade, perhaps even rebellion from within. The great cities were swallowed by trees, their voices silenced. Angkor in Cambodia, Easter Island in the Pacific, Cahokia in North America. Each tells the same story in different words. Brilliance followed by silence. Now, extend that same rhythm into the deep time of Earth. The fossil record is a ledger not just of life, but of collapses, bursts of creativity, sudden extinctions, fragile recoveries. The Cambrian explosion, when complex life appeared almost overnight. The great dying at the end of the Permian, when nearly all species vanished. The extinction that cleared the dinosaurs and opened the way for mammals. Each of these looks eerily like the rise and fall of civilizations written in biology. Sudden ascent, violent collapse, a reset. If intelligence has risen before, this is what it would look like. Not cities preserved in stone, those vanish too quickly, but scars in the earth itself. Carbon spikes frozen in sediments, isotopic fingerprints that don't match natural processes, synthetic particles embedded in ancient rock, traces of technologies that outlast the builders but not the meaning. Each cycle would leave a pulse of activity, each collapse a silence, and then the planet tries again. That cycle has a name in modern astrobiology, the Great Filter. It's the idea that life may be common in the universe, but intelligence rarely survives its own adolescence. Civilizations may bloom like flowers, but most wither before they seed the stars. The silence we hear when we point our telescopes outward may not mean we're alone. It may mean most others have already burned out. What's terrifying is how well the Great Filter fits our current trajectory. We've split the atom and salted the soil with isotopes that will be readable millions of years from now. We've pushed atmospheric CO2 to levels not seen since prehistoric hothouse Earth. We've covered the oceans and continents with plastics, leaving a layer of synthetic dust that will never fully decay. In just a few centuries, we've produced the exact kinds of anomalies scientists now puzzle over in ancient rocks. we're already the ghost of civilization future geologists would wonder about. We began this journey with something small, metallic spheres sealed in stone, objects so strange they made us question whether we truly know our own past. From there, we followed the trail across fossils, atmospheres, isotopes, polymers, the moon, and the stars. Each clue was faint, each fragment incomplete, but together they whispered a possibility almost too large to comprehend, that we may not be the first civilization to walk this earth, and if that is true, then we're also not the first to fall. The fossil record pulses with extinctions and recoveries, a rhythm that feels less like accident and more like memory. The isotopes, the atmospheric scars, the inexplicable anomalies, they may be warnings written into stone saying, others were here, they reached this point and then they vanished. But there is another way to read them. Perhaps they are not only warnings, perhaps they are proof that intelligence itself is resilient, that consciousness rises again and again, like a flame the earth cannot extinguish. If so, then we are not standing at the edge of a cliff, but at a fork in the path. Collapse is one direction, endurance the other. The silence of the cosmos presses on us. We see no galactic empires, hear no voices from the stars. Perhaps the filter is real, and most civilizations destroy themselves before they spread. But silence is not proof of failure. Silence is an invitation. If no one has survived long enough to leave a clear beacon, then maybe it is our role to be the first, because the greatest mystery isn't whether others came before us. The greatest mystery is whether we will be here tomorrow. If you like the video, don't forget to leave a like and subscribe. It makes a huge difference and helps the channel grow.